This video is going to go through an example of a projectile motion calculation. A faulty fireworks rocket launches but never discharges. If the rocket launches with an initial velocity of 43 feet per second at an angle of 80 degrees, how far from the launch site does the rocket land? First, we will draw a picture of our situation. We have the initial velocity of our rocket at 43 feet per second at an angle of 80 degrees. We will define up as positive and down as negative. We are trying to find how far from our launch site the rocket lands. Next, we will write down everything we know. We know the initial velocity is 43 feet per second, the angle alpha is 80 degrees, and we are trying to find s sub x, or the displacement in x. There are a couple of basic equations that we will need to solve this problem. We need to separate out the x and y components of the initial velocity because motion in x is independent of motion in y. The x component of velocity is found by taking the magnitude of the velocity and multiplying that by the cosine of our angle alpha. The y component of velocity is found by taking the magnitude of velocity and multiplying it by the sine of the angle alpha. Next, the displacement in x, or s sub x, can be found by taking the velocity in x and multiplying it by the time the rocket is in the air. Remember, when we are thinking about motion, there is no change in velocity in the x direction because gravity does not act in the x direction. Last, time can be found by taking the final velocity in y minus the initial velocity in y divided by the acceleration, which will be the acceleration due to gravity, since that is the acceleration acting in the y direction. Now that we have identified our basic equations, we can go ahead and start our substitution. First, we are going to substitute to find the x and y components of the initial velocity. V sub x can be found by taking 43 feet per second and multiplying by the cosine of 80 degrees. This gives us 7.47 feet per second for v sub x. V sub y is equal to 43 feet per second multiplied by the sine of 80 degrees. This gives us 42.3 feet per second for an initial velocity in y. Now, since we don't know time yet, we cannot find the distance in x. However, we can calculate the time by taking the final velocity in y minus the initial velocity in y divided by the acceleration acting in y. Since the only force acting on the rocket right after it launches is gravity, the initial velocity in y is equal in magnitude but opposite in direction to the final velocity in y. That means the final velocity in y is a negative 42.3 feet per second. We can substitute in the final velocity of negative 42.3 feet per second and subtract 42.3 feet per second and divide this by the acceleration due to gravity of negative 32.2 feet per second squared. Remember, the acceleration due to gravity is negative because it is acting in the downward direction, and we defined downward to be negative. Once we divide, we get a time of 2.67 seconds. That means the firework is in the air for 2.67 seconds before it hits the ground. Now that we know time, we can substitute to find s sub x. We will take the velocity in x, which is 7.47 feet per second, and multiply that by the time of 2.67 seconds. This gives us a distance in x of 19.9 feet. This concludes our projectile motion example.